Hello everyone, this is a continuation of our Numpy tutorials. If you have not seen my first two tutorials, then I would say pause right now, go watch them first, and then you can continue on this one. Here is the list of topics that we are going to cover in this tutorial. Okay, let's first begin by indexing and slicing. Now you all know that when you have a normal Python list like this, you can use the index range like this to get the list of elements. So when you do n0 to 2, what it will do is it will go from 0 to 1. So this is 0, 1, 2. It will not cover 2, but it will cover these two. So that's what it does. It also supports -1 index. So -1 means start from the end, so it will print the very last element. Okay, now numpy array supports similar kind of slicing. So here I'm going to create numpy array. I will initialize it with same elements, and if you do 0 to 2 here, you see you get the same result as what you got with a normal Python list. Okay, it also supports reverse index. So the syntax is pretty similar to list, how you slice the list. So if you know list slicing, then you can use the same concept for numpy array as well. Now let's go through a multi-dimensional array. So here, let's say I have a multi-dimensional array. So if you print it, it looks like this. Now here, when you do a12, what will happen is you are going through the, so here this is a row, this is a column. Okay, so this is 0th row, 1 row. So you are going through this first row and you are looking at the second element, so 0, 1, 2, so which is 3. Okay, so that's what it is printing. When you do something like this, what will happen is it will go through 0 to second row. Okay, now always when you are doing slicing, this particular index is not included, so it will actually go from 0 to 1. So 0th row, first row, and then it will print second element. So in these two rows, the second element is 8 in 3, so that's what it is printing here. You can also do a -1. Oops. So a -1 is the last element. So last element here is this last row, so that's what it is printing. And in that last row, so always remember this is your row, and after row you have column. So let's say in column you want to print column 0 to 2. So 0 to 2 means 0 and 1. So it's in the last row, it's printing 9 and 3. Now let's say if you want to go through all the rows and print these two columns. Let's say you want to print 723 and 832. How will you do that? So the syntax for going through all the rows is just a column. So if you have just a column, it will go through all the rows, and then now you want to go through first row and second row. So to include first, you will say first. Now if I say second, it will not include this guy here. Okay, so I have to say 3 here. Cool. Now let's see how you would iterate through an array. So I'm going to initialize the same array here, and if you look at this array, it's sort of like a table. You have rows and you have columns. Now if you want to iterate through rows, you will just say for row in A, print row. Pretty straightforward. Okay, and if you want to print individual cells, then again row is also sort of like a list, so you can iterate through it and you can print individual numbers. Okay, now sometimes you want to flatten the list and print every cell. So numpy has this method called flat. You can do for cell in a.flat print cell. What this is doing is it is just flattening this as if it's a single dimensional array, and you can now iterate through the entire array. Next item is stacking two arrays together. So for example, let's say you have these two arrays. So what I'm doing is I'm initializing array with numbers 0 to 5, and I'm reshaping it by 3 by 2 shape. Okay, and then I have my B, which is like this. So if you print A and B, it looks like this. Okay, so you have got, let's say, two-dimensional arrays. Now if you want to vertically stack them together, just imagine you have put this array as if it's a box and you're putting this over another box. Okay, so numpy supports that. So in numpy you will do np.vstack A and B. Okay, I had a problem with the syntax. The argument is tuple actually. Okay, so you can see that it kind of stacked them together as if there were like two boxes and you just put one box over the other. Okay, you can do same thing with horizontal stacking as well. So let's say these are two boxes and you want to horizontally put them side by side. You can do the same thing with hstack command, which is horizontal stacking. So you can see 0 1 3. So this was my first array and this is my second array. This could be pretty useful feature based on what kind of requirement you have. All right, now what we are going to look at is the horizontal split. So I'm again initializing one more array, and this array is having 2 rows and 15 columns. Now if you want to split this array into, let's say, 3 different arrays, so I want to just imagine I am vertically slicing them into 3 different equal size arrays. You can do that using hsplit command. Hsplit command is at numpy module, it is not at individual array. If you do that, you can see that it kind of split into 3 different arrays. Now it's kind of hard to visualize this, so what I'm going to do is I'm going to store the result into a variable, which is a list, and just print those things one by one. So you can see that now I kind of vertically slice these big array into 3 different arrays by doing hsplit. So 3 means divide it into 3 different equal sized arrays. Okay, now you can do the same thing with a vertical split. Here I can do a vertical split, which is, let's say I have only 2 rows, so I could just divide it into 2. I can make only 2 divisions out of it. So if you do result 0 and result 1, they look like this. So what I did is vertically I kind of cut them into 2 arrays. So this the second argument tells you like how many partitions you want to make out of your original array, which is here. Okay, now another topic we want to cover is indexing with boolean arrays. This is pretty powerful. It's kind of like non-intuitive. If you have just used list, then you will never think that this kind of awesome feature exists in numpy. So I'm going to initialize one array and kind of reshape it to 3 4. By the way, this practice is quite popular. Whenever you want to initialize array with fixed set of numbers and then you want to kind of reshape it, this is what you do. This is better than kind of typing all these elements by hand, you know. So I kind of like it. Okay, now I have got this numpy array. All right, now let's say I have this b variable, and if I do a greater than 4, what's gonna happen is it's gonna create another numpy array, and it's gonna store the result of this expression into individual elements. So here 0 is not greater than 4, so it's false. versus 11 is greater than 4. So at that location it is true. Okay, so pretty cool. I got now two arrays. This one is numbers and this one is boolean. Now what you can do is something like this. Now you might not have seen this before. Okay, so here this is array and the index of that array is array itself. Now let's see what's going to happen when you do this. Okay, cool. So what it did is it looked at B array and then wherever it found true, it returned those elements from this original array. So you can see that 5 to 11 were true. That's why you got 5 to 11. This is a cool way of extracting all the elements which are greater than 4 from your original array. This is also useful if you want to replace those elements with a certain number. So for example, I can say a of b is equal to -1, and what will happen is any element that was greater than 4, you wanted to replace it with -1, and that's what it did. So b, it looks at all the true elements, it returns those elements, and all those elements are set to be -1. This could be really powerful based on what kind of application you're writing. Okay, so that was all about Numpy array functions. I hope you're having fun time learning Numpy. It's pretty powerful. Numpy arrays are very fast and memory efficient. So if you are doing a lot of data manipulation and if you're looking for performance, please use Numpy. It's very popular in data science and scientific community overall. All right. Thank you for watching. And if you like this video, please give it a thumbs up. If you have a question, please post a comment below. Bye.